Number 1, the line graph shows the estimated number of chipmunks in a state park on April 1st of each year from 1989 to 1999. Who's counting these chipmunks? I don't know. Based on the line graph, in which year was the estimated number of chipmunks in the state park the greatest? Anytime we have a line graph, or any graph for that matter, we want to see how the different axes are labeled. So here our x-axis is the year, and we said it was 1989 to 1999, and yeah, we see that there. Then our y is the estimated number of chipmunks, and that's what we want to know. When was the estimated number of chipmunks the greatest? So what's the highest point? And if we look over at this line graph, it looks like right here was the highest point, the highest number of chipmunks at 150. And so we follow that down, and it looks like that year was 1994. And there, B, 1994 is my answer. Number 2, a fish swam a distance of 5,104 yards. How far did the fish swim in miles? Now, if we look at this, this is one you can use your calculator or you can estimate it. Either way is going to get you the right answer. So here's our 4 answers, and if you look at them, they're all wildly different. We have here 0.3, less than 1. Then we have 2.9, or around 3. Then we go up to 3,000 and change, and then almost 7,000. Okay, so first, I think even without doing, frankly, any estimating, we can get a good answer here just by sort of logic. Let's look at it. A fish swam a distance of 5,000. Just draw a little fish. Haha, happy fish. Fish swam a distance of 5,104 yards. How many miles? 1 mile is 1,760. So I know he swam more than 1 mile because 1,760 is less than 5,104. So 0.3 miles, no, that's wrong. He swam more than that. How many times more? Well, here, this is, if we round this to thousands, this is 2,000 if we rounded. And here, this is around 5,000. How many times would 2,000 go into 5,000? How many of these would we have? It's not going to go in 3,000 or 6,000, 7,000 times. It's going to be about 3. That's the only one that makes logical sense. If we look at this and say, okay, how far did the fish swim? And they're telling us, how many yards are in both. That's it. And we can absolutely put this into our calculator. 5,104 divided by 1,760 does give us 2.9, or B is my answer. Here they're really counting on students to have misread the question, done some math incorrectly. But yeah, sometimes too, if like with word problems can trip students up. Just drawing a little sketch like this can help you visualize what's going on and make sure that you don't miss these problems. Right. On to number 3. Which expression is equivalent to 12x cubed minus 5x cubed? Anytime we are combining like terms, these are terms that are alike, hey, go figure, they have to match exactly. So if I have, 5x squared minus 4x squared, I can do that because I have 5x squareds, and I'm taking away 4 of those x squareds. But if this was just 4x, I can't. They don't match. So here, 12x cubed minus 5x cubed, they do match. So if I had 12x cubeds, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and I took away 5 of those x cubes, 1, 2, 3, 4, 5, how many do I have left? Well, I have 1, 2, 3, 4, 5, 6, 7 x cubed. So 12x cubed minus 5x cubed is 7x cubed, and that is going to be C. Let me change the color. There we go. C is going to be my answer. Yes, this is very important here. You can see what they're trying to trip you up. What they're trying to get people to do is to add the exponents, to add those together. No, if we are adding or subtracting, those exponents are going to stay the same. Don't get this confused with multiplication division. When you're multiplying and dividing things with exponents, yeah, there's going to be some combination of exponents going on. That is not the case when we're adding and subtracting. It is, as I said, we're saying I have 12x cubed and I'm taking away 5x cubed. How many x cubed do I have? I have 12 minus 5, or 7. Number 4, x plus y equals 18 and 5y equals x. What is the solution x and y to the given system of equations? Anytime you have a system of equations, you can solve through substitution, elimination, or graphing. Those are your best bets. And which way you choose will depend on your comfort level and the problem that's given. Graphing you can always do. It may not always be the fastest solution. Any of these will always get you the right answer. You can always choose any of them. Substitution, elimination, or graphing. But we want what is most accurate, what you're the most comfortable with, and what's fastest. For me, this particular one, when I look here and I see x is equal to 5y, I immediately think substitution, because I have this variable x has already been isolated. I'm told x is 5y, so I can take that 5y and plug it into the other equation. Wherever there's an x, boom, I've got my x, I got my y solved very easily there. Again, if you want to graph this, totally fine. You're going to be looking for, these are both linear because we don't have any x squareds, we just have an x and a y. We're going to have two lines. We're going to be looking for the point where they cross. That is going to be your solution. So if we do this mathematically instead of graphically, and I said I'm going to do substitution because that 5y equals x seems like that's a perfect candidate for substitution. So wherever there's an x up here, I'm going to substitute 5y. So I'm going to put it in right there. So now I have 5y plus y equals 18. I'm going to write this down here. 6y equals 18. Since 6 times y equals 18, I need to undo that to solve for y. The opposite of multiplying by 6 is dividing by 6. And I get that y is equal to 18 divided by 6, or 3. Now that I know y is 3, that's part of my answer, I need to find out what x is. Well, I'm told here that if I take my y and I multiply it by 5, I'll get x. So 3 times 5 is 15. There's my x, 15. And over here, 15, 3 is A. That is my answer. Number 5, the point 8, 2 in the xy plane is a solution to which of the following systems of inequalities? Okay, so 8, 2, that means my x is 8 and my y is 2. So let's look at these. They're just saying greater than or less than 0. Well, before I even look over here, I can just say, okay, is this greater than or less than 0? It's greater than. So I know that x must be greater than 0. And again, I'm getting this because I looked over here and saw all of them were some combination of greater than or less than. That x is greater or less than 0 and y is greater than less than 0. So I'm just looking at the problem by itself before I look at which answer matches it. Then I have y equals 2. 2 is greater than 0, so y must also be greater than 0. And if I look over here at my options, right off the bat, there we have A is x is greater than 0 and y is greater than 0. Let me double check my other answers just to make sure I haven't missed anything. B, this right here, y is less than 0, that's wrong. C, x is less than 0, that's wrong. And D, both are less than 0, that's wrong. Confirmed, A is my answer. Number 6. The absolute value of x minus 5 equals 10. What is one possible solution to the given equation? They're being nice here in that they're saying one possible solution, so you can give either of the possible solutions. Always be careful. They love to say what is the positive solution to this or what is the negative solution to this. And then you give a solution, but it's not the solution they were looking for. Watch out for those. This one is nice. Again, they're just saying what is one possible solution. Okay, so absolute value means whatever is inside here, when you take the absolute value of it, it turns positive. So before I took the absolute value of this could have been positive or negative. But once I turn it positive, I get 10. So that means there's two different equations that this could have been. What it could have been is that x minus 5 just equaled 10. So when we turned it positive, it was still 10. Or it could mean that x minus 5 equaled negative 10, and then when I took the absolute value, it changed it to positive 10. So I can solve either of these equations, and I will get one of two possible solutions. I only have to enter one of them, but I wanted to show you both. All right, so on the left-hand side here, we have x minus 5 equals 10. So to undo that 5 being subtracted, I need to add it to both sides. So on the left, that minus 5 plus 5 cancels out. I just have x. On the right, 10 plus 5 is 15. My other option here, x minus 5 equals negative 10. Same thing. I need to undo the minus 5 by adding 5. So on the left, minus 5 plus 5 cancels out. I just have x. And on the right, negative 10 plus 5 is negative 5. So either of these will work, 15 or negative 5. Only enter one of them. Again, just as a general SAT rule, always go back and double check which one they are asking for before you enter it, because obviously in this case, if they had said, what is the negative solution, you would have chosen negative 5. If they said, what is the positive solution, you would have chosen 15. This time they're being nice, you can use either one. Number 7. F of x equals 7x plus 1. The function gives the total number of people on a company retreat with x managers. What is the total number of people on a company retreat with 7 managers? Anytime we have a function, like say f of x equals, I don't know, 3x squared. Doesn't matter. Just a function. What they're saying is if I pick an x, pick an x like f of 1, my x I've chosen is 1. What will happen when I plug 1 in and then I do all the math? What result do I get? That result would be what f of 1 is. So like in this example, I'd say, okay, I'll plug in a 1 wherever there's an x. There's 1x right there. X squared, 1 squared is 1, times 3 is 3. So when I put 1 into this function, I get 3. F of 1 is 3. That's how we handle functions. So in this case, we have that f of x equals 7x plus 1, and we're told that x is the number of managers. So if I plug in the number of managers and do the math, I will get the function. The function gives the total number of people. So I will get the total number of people. Okay, so how many managers are on this corporate retreat? You're told it is 7 managers. So I need to plug in a 7 for the managers, and I'll get that total number of people because that's what they want. They want to know what is the total number of people. So 7 times 7 plus 1. 7 times 7 is 49 plus 1 is 50. So my total number of people, the result I get after I do this math, is 50, and that is my answer. Number 8, h of x equals x squared minus 3. Which table gives 3 values of x and their corresponding values of h of x for the given function h? Okay, as we just mentioned in number 7, when we're talking functions, we have x values, usually, that we are plugging in to our function, and we're seeing what results we get after we do all that math. And that result that we get is our h of x. So we have 3 tables here, and this one is when we don't have to try every single table. We don't. A couple little shortcuts that can save us some time. All right, so first I'm looking at the options here and which one has a different option for the output, for the h of x, for a given number. So like, would it be this column, or this column? Which one is going to eliminate the most answers right off the bat? Well, let's see here. I've got output of 4, -2, -1, -2. 3 different answers. Okay, that's pretty cool. 5, 1, 1, and 1 in the second column. 2 answers. No. 6, 6, 3, and 3. 2 answers. I want to use the one that has 3 different answers, has the best chance of eliminating the most. It may not, it may end up being -2 is the one we're looking at, but let's just try it. Okay, so we're plugging in 1 for each of these and plugging 1 into this equation. So 1 squared minus 3. 1 minus 3 is -2. So, okay, that eliminates A, since it said it would be 4, so A is out. And that eliminates C, since it said it would be -1, C is out. Now I am not going to try 2. Why? Because it won't do me any good. My 2 remaining answers, B and D, when I put 2 in, they both say I will get 1 out. So don't waste your time on that one. Move on to this number 3 here on the end. Sorry, I think my desk is making some noise here. Trying to avoid that. Let's plug in 3 because this one is giving us 2 different answers. So if I plug 3 into this equation, 3 squared minus 3, or 9 minus 3, I will get 6. And hey, B says that if I plug in 3, I will get 6. D says I'll get 3, so that one is out. B is my answer. Number 9, the function f is defined by f of x equals 270 times 0.1 to the power of x. What is the value of f of 0? Wow, 3 function questions in a row. Okay, so once again, f of 0, when we say f of 0, it's saying, because this is an f of x problem, everywhere that there is an x in this equation, we will plug in 0 and then see what result we get. So let's do that. We have 270 times 0.1 to the power of x. We want to know what happens when x is equal to 0. So let's plug in a 0 there for x. And you do not multiply first. Remember our order of operations, parentheses, exponent, multiplication, division, addition, subtraction, and these are pairs. Okay, so parentheses, there's nothing inside the parentheses. Next thing is exponent, so we need to do that next before we multiply. The exponent 0, 0.1 to the power of 0 is just 1. Any number to the power of 0 is going to be 1. And so 270 times 1 is equal to 270. And that is D. There's my answer. Number 10, to estimate the proportion of a population that has a certain characteristic, a random sample was selected from the population. Based on the sample, it is estimated that the proportion of the population that has the characteristic is 0.49, okay? With an associated margin of error of 0.04. That's my margin. We'll say margin of error. I'll write it like that. Based on this estimate and margin of error, which of the following is the most appropriate conclusion about the proportion of the population that has the characteristic? Before I even look at their answers, margin of error is like, I think the answer is 0.49, but I could be off by this much in either direction. I could be that much more or that much less, but that's my confidence. So if I said, I think the answer is 10, but I have a margin of error of 1, then it means the answer could be 1 less than that, 9. It could be 1 more than that, 11. That's what margin of error is. So here they have an estimated margin of error of 0.04, excuse me, associated margin of error of 0.04. So what they're saying is we think that it's in this range. We're pretty sure it's in this range. If I go down 0.04, if I subtract 0.04 from 0.49, I will get 0.45. And if I were to add it, it would be 0.53. So this is the range. We think it's 0.49, but it's within 0.45 to 0.53. Okay, let's look at our answers. A, it is plausible that the proportion is between 0.45 and 0.53. Right off the bat, that looks pretty good, but let's look at the rest just to make sure. B, it is plausible that the proportion is less than 0.45. Nope. That's what this is saying, is that these are the outer limits, 0.45 and 0.53. saying it's plausible that it's down here? No. On this like little number line that we're creating? Nope, that is not plausible. C, the proportion is exactly 0.49. No, they have a margin of error. It could be anywhere in this bucket. It's not necessarily 0.49. So C is out. D, it is plausible that the proportion is greater than 0.53. Again, that would be over here on, that would be over here if this is a long number line. This would be over here. Nope, it's supposed to be in this range. So D is out, and my first one, which I said looked correct, is correct. It is A. It is plausible that the proportion is between 0.45 and 0.53. Number 11, a moving truck can tow a trailer if the combined weight of the trailer and the boxes it contains is no more than 4,600 pounds. Okay, so I've got a moving truck, and it has a trailer. High-tech drawing here. And so it can do this if the combined weight of the trailer and the boxes on it is 4,600 pounds. So I'm going to say the trailer plus the boxes has to be equal to? No, it's not, because it says no more than. So it could be less than that. It doesn't have to be 4,600 pounds. So it has to be less than or equal to. It could be 4,600 pounds, but no more. Okay, so there's my equation representation of what this moving truck can haul. So they're asking, what is the maximum number of boxes this truck can tow in a trailer with a weight of 500 pounds if each box weighs 120 pounds? All right, I've already got this equation. I can just modify a little bit, and I will have a good setup to solve. So for my little second sort of variation on this, I'm going to write it below instead of modifying my original. We're told the trailer weighs 500 pounds, so I'm going to replace that T for the trailer with 500. And then I want to know how many boxes. Well, each box weighs 120 pounds, and we're talking about that altogether this has to be less than or equal to 4,600 pounds, and the trailer is 500 pounds. Well, how do I represent that each box is 120 pounds? If I had one box that weighed 120, this would be 120, right? If I had two boxes that would weigh 120, this would be 240, or 120 times 2. So if I say B is my number of boxes, then it would be 120 pounds for each box, 120 times B. So there's my equation, and I need to solve for B. 500 plus 120B is less than or equal to 4,600. So I'm going to subtract 500 from both sides to get rid of it on the left. I have 120B on the left and 4,600 minus 500, or 4,100 on the right. All right, so to solve, I need to divide both sides by 120. And I'm going to do this on my calculator because time is of the essence in the SAT, and I think that's going to be the fastest way to divide this. So on the left, I just get B. And then on the right, 4,100 divided by 120 is 34.17 repeating. Is that my answer? 34.17 repeating? Well, let's look at the question again. The question says, what is the maximum number of boxes the truck can tow? Can it tow 34.17, or excuse me, 16 repeating? Oh, I got that wrong. Perish the thought. 16 repeating. There we go. 16 repeating. So can it actually tow 34.16 boxes? Well, there's no such thing as 1.16 repeating boxes. 1/6 of a box. It doesn't happen. So what can it be? It has to be a whole number, and it must be less than or equal to 34.17. So it's just 34. And there is my answer. A is 34 boxes. All right, on to number 12. Negative 4x squared minus 7x equals negative 36. What is the positive solution to the given equation? There's two ways that you can do this, or more than two ways that you can do this. I would absolutely graph this, 100%. Just done. Yeah, I would not bother with trying to factor it because you've got this, you know, the negative 4x squared. The graphing's going to be the fastest. Absolutely. I'm going to show you how to do it in other ways, but, you know, we're graphing the sucker. We want to get it done quickly. To get this equal to 0 so that I can solve using quadratic formula or see if it's possible to factor it, I'm going to move everything over here. So first that 4x squared, negative 4x squared, I'm going to add a positive 4x squared to either side. So that gives me a negative 7x equals 4x squared minus 36. And then I'm going to add 7x to both sides. And I'm going to get 0 is equal to 4x squared plus 7x minus 36. Now, to see if you could factor that, you would multiply those two together. Negative 36 times 4 is negative 144. And we would say what things multiply to negative 144 but add to a positive 7. So you'd want two numbers that were pretty close together. So, and I'm just going to write the positive versions, but know that for these combinations of numbers, one has to be positive and one has to be negative. So 12 times 12 is in there. Let's see, 9 goes in there. Oh, I'm blank 16 times. There we go, 9 and 16. And let's see, actually, and then I'm not going to, as I'm writing these down, I'm not going to go any further because I see that the difference between 9 and 16 is 7. But you absolutely can keep going and keep writing all of those factors out there. 3 is going to go in there, 2 is going to go in there, 4 is going to go in there. You can definitely write those. But when you're doing this by factoring, as soon as you see a pair where the difference is 7, because we're talking about a positive and a negative, I don't know what just fell over, then we would need to, just for the interest of time, just kind of stop right there. All right, so which of these would need to be negative to get a positive 7 if I add them together? That's going to be a negative 9. Negative 9 plus a positive 16 is going to equal a positive 7. Okay, so negative 9 and 16. So I'm going to go over here and I'm going to pair them up. I'm going to have 4x squared plus 16x minus 9x minus 36. And then I'm going to factor by grouping. So in this first group, I can pull out a 4x. And that leaves behind x plus 4. And I want this second group to also be x plus 4. So what can I bring out of here to make that happen? It's going to be a negative 9 is what I'm going to pull out. And then these combine together to be 4x minus 9 times x plus 4. And then we solve each of these separately. So 4x minus 9 equals 0. Because all of these, I didn't write it each time. I should have. I'm sorry. Should have been equals 0 the whole time down. And then x plus 4 equals 0. All right, so on the left, 4x minus 9 equals 0. I need to add 9 to both sides. And I get 4x equals 9. And then I'm going to divide both sides by 4 to get rid of that times 4. And then I get x equals 9/4 or 2 1/4 or 2.25. And then up here, my other one, the opposite of adding 4 is subtracting 4. So I add 4 to both sides. Excuse me, subtract 4 from both sides. So I get x on the left and negative 4 on the right. So my two values of x are 9/4 or 2.25 and negative 4. Now, so is that, look how much space that took to do that. Is that possible? Absolutely. Can you also solve it using the quadratic formula, which is, negative b plus or minus square root of b squared minus 4ac all over 2a, and you use and from this right here, you would use 4 is your A, 7 is your B, and negative 36 is your C. Can you solve it that way? Absolutely. More power to you if you decide to do it. What's going to be the fastest? It's going to be graphing. Absolutely. Once I would change it into this and then I would put it in your graphing calculator as y equals 4x squared plus 7x minus 36. But frankly, you can just stick it in just like this into your graphing calculator, and you're going to get an XY graph like that, and you're going to get two vertical lines that are going to represent your two answers. And you just see what the X value is for those. It's the fastest, absolutely the fastest go graphing all the way on this one. But we have our two options, and we said our two answers were 9/4 or 2.25 and -4. And they wanted the positive solution, so that is going to be right there, the 9/4 B. Yeah, I think it's helpful to know how to do this, to do the factoring, because there are some problems where you have to do it. And like the quadratic formula, absolutely, there's problems where you need the quadratic formula. Ones like this, psh, graph it. Number 13. The table summarizes the distribution of color and shape for 100 tiles of equal area. If one of these tiles is selected at random, what is your probability of selecting a red tile? Express your answer as a decimal or fraction, not as a percent. Always, always, always double check their instructions for things like this where it is a student-produced response. We don't want to get the right answer, but then mark it on their sheet incorrectly. Or mark it in the computer incorrectly, I should say. Okay. We want to know what's the probability of selecting a red tile. So probability is always going to be a part out of a whole. So in this case, the part is red tile. And the whole would be all the tiles. Because they're all in a bag together, I'm assuming. Now, it does not specify whether this tile must be square or pentagon. It doesn't matter. All that matters is whether it's red or not. So what is our red tile? Well, if you look in the red tile column, it's telling us there are 10 square tiles that are red. There are 20 pentagon tiles that are red, for a grand total of 30 red tiles. So 30 is my number of red tiles. And all tiles, I'm going to look over here where the totals converge, is 100. It goes either way. If I had 30 plus 30 plus 40, it equals 100. Or if I had 55 and 45, it equals 100. There are 100 tiles total. And they want your answer as a decimal or a fraction. So 30 over 100 can be simplified. You divide both of them by 10. It becomes 3/10. So that would be my fraction. And if I wanted to express that as a decimal, it would be 0.3. So make sure to do that, because as they say, don't do it as a percent. So do not put 30 in there and say, oh, I meant 30%. Nope. They said don't do it as a percent. So it's going to be either 3/10 or 0.3 as your answer. Number 14, another function. Man, a lot of functions in this one. F of x equals 2x plus 3. For the given function f, the graph of y equals f of x in the xy plane is parallel to line j. What is the slope of line j? It's a function problem, but it's really just a slope-intercept form of a line problem. So this function f of x equals 2x plus 3, we could also think of it as just a line, that is y equals 2x plus 3. And I love how their verbiage, for the graph of function f, the graph of y equals f of x in the xy plane is parallel to line j. We've got a line, y equals 2x plus 3, somewhere out there. There's my y equals 2x plus 3. She's probably going to be more like that. Somewhere out there, there's another line that is parallel to it. What is its slope? Two things that you need to know to answer this correctly. That lines that are parallel have the same slope. Always. Always, always, always. That's a good fact. Keep it in your head. It's a good one for the SAT. So it has the same slope. Next, we need to look at this line that is in slope-intercept form and say, what is its slope? Well, as it is in slope-intercept form, it's really nice and simple. The 3 that's out here by itself is always going to be your y-intercept, and the number that's right next to the x is always going to be your slope, assuming that it's set equal to y, or in this case, f of x. Same difference for our purposes here. So our slope then is 2, and we have a line that's parallel to that. It must have the same slope. Its slope is also 2. That's your answer, 2. Number 15. A proposal for a new library was included on an election ballot. A radio show stated that 3 times as many people voted in favor of the proposal as people who voted against it. Okay, so I'm going to say we have here against and we have in favor of. So the people who were against it, I'm going to say there were X number of people that were against it. And it says 3 times as many people were in favor of it. So 3 times X. A social media post reported that 15,000 more people voted in favor of the proposal than voted against it. Based on these data, how many people voted against the proposal? So 15,000 more people voted on it. So this number that was against it, 15,000 was added to that, and that equaled how many were in favor of it. Okay, 15,000 more voted in favor. So that original number X, 15,000 was added to it, and it equaled those in favor of it, which we also said was 3X. Now the question they're asking us is, based on these data, how many people voted against it? So we're solving for X. And with our little equation we've just made here, that X plus 15,000 is equal to 3X, we can solve for it. So I'm going to subtract X from both sides to get all the X's over here. So I'll do that. I get a 15,000 left on the left. 3X minus X is 2X. And so now to solve for X here, X is being multiplied by 2. So I need to do the opposite. I need to divide by 2. And I get just an X on the right, and 15,000 divided by 2 is 7,500. That's my X, and that is how many people voted against it. A, 7,500 is my answer. Number 16. In the figure, lines M and N are parallel. If X equals 6K plus 13 and Y equals 8K minus 29, what is the value of Z? Now it's saying figure not drawn to scale because they don't want us to just kind of eyeball it and say, well, Z looks like it's about, look at these answers, it looks like it's about this number of degrees. We can't do that. We have to do the math. So they're parallel, and parallel lines have certain traits. If we have a set of parallel lines and a transversal. In parallel lines, and if you want to know the reasons why this works, I'll put links down below. I always add extra videos in the description if you want to learn more about these concepts. But just this right here is what you need to sort of know and memorize for the SAT. There are going to be matching sets of angles. So all these that I'm highlighting in green here are matching. And then all these that I'm doing in red also match. So all the green match each other and all the red match each other. And the reds and greens are always supplemental. So they will always add up to 180. Any green plus any red will add up to 180 degrees. Now, if you're looking in your geometry textbook, there's going to be all kinds of theories for this and theorems, and they'll say like, alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. There's a whole slew of them. For the SAT, they never ask you for those kind of reasons. They don't ask you, can you prove this? Can you say which theorem it is? For the SAT, not for your geometry class, for the SAT, you don't need to know those theorems. This is all you need to know. This truth, that in parallel lines crossed by a transversal, these are the angles that are the same, and these are the angles that are supplemental. Okay, so over here, I have that X and Y. Those are the same. I know that because of what I know about parallel lines, but also just intersecting lines. Vertical or opposite angles are going to be congruent. Depends on your book whether they're called vertical angles or opposite angles. I've seen both. So I know they're the same. So if X is 6K plus 13 and Y is 8K minus 29, they're the same. I can set those equal to each other. I can say that 6K plus 13, my X, is equal to 8K minus 29, my Y. And now I've only got one variable and I can solve for that variable. So let's do that. I'm going to first get rid of that 6k on the left, get all the k's on the right. I just have 13 is equal to 8k minus 6k is 2k minus 29. Then to get rid of that 29, that negative 29, I'm going to add 29 to both sides. So I'm going to get on the right-hand side still 2k. And on the left, 13 plus 29 is 42. So to solve for k, since k is being multiplied by 2, I'm going to do the opposite. I'm going to divide by 2. And I get that k is equal to 42 divided by 2, or 21. Now, look over here. They've got 21 as an answer. They are counting on someone getting to this point, solving for k, not going back and looking at what the actual question is, marking B and going on and getting it wrong. We don't want that to happen. Always, always, always go back and check to make sure you are 100% clear what they are asking, because it's very easy after you've done all this math to get to a stopping point and go, oh, 21, boom, there we go, I'm done. They didn't ask for k. They asked for z. What is z? Look up here. Z is this angle right here. And if we're looking at our little reference, that is not a green like x and y are. It is a red. So it is supplemental to x and y. If I add one of those greens to this red z, I will get 180 degrees. Well, what are the values of x and y? Are they 21? Nope, they are not 21. They are either 6k plus 13 or 8k minus 29. Both will get me to the right answer. I'm going to go with 6k plus 13. So I plug 21 in here for k. 21 times 6 is 126. Then I'm going to add 13 to that, and that will give me 139. So to find the value of z, I know that x or y plus z is 180. So x and y are both 139 degrees. And I'm going to add z to it. I will get 180. So to solve for z, I need to undo this. I need to undo this adding of 139 by subtracting 139. And when I subtract 139 from both sides, I get that z is equal to 41. And my stylus went wrong on me there. Let me zoom in so I can circle it correctly. C, 41 is my answer. That is the value of z. Number 17, 3x plus 21px equals 84. In the given solution, p is a constant. The equation has no solution. What is the value of p? Okay, when we say an equation, a linear equation, has no solution, it means that I'm going to end up with two things equal to each other that are not possible. Well, what would fall in that category? What would be not possible? If I can get it down to just numbers, I get rid of all the variables, and I end up with something like 7 equals 4. That's not possible. That's not true. There's no solution. If I get something like x equals x plus 1, that's not possible. It's just not. If it's x minus 1, x equals x minus 1, no, it's not possible. And if anyone out there is thinking like, well, what about weird cases? What about 0? What about things? Think of it in terms of a number line. Any real number is on a number line, right? Somewhere on there. You know, even if it's like, if it's pi, like if this is 0, 1, 2, 3, you could represent pi as a dot on this number line. Any real number is a dot on the number line. And if I add 1 to a dot on a number line, it moves, right? It moves 1 to the right. If I subtract 1, it moves 1 to the left. No matter what it is. If it's 0, if it's a square root, if it's a number, it's going to move. So a number, wherever that number is, and a number that is 1 greater or 1 less than that cannot be the same. No exceptions, no way. So we've got some variables here. It doesn't look like we're going to be able to get a like 7 equals 4. Like we can't get rid of these variables. But let's see if we could create one of those situations where it's like x is equal to x plus 2. You know, something that's impossible. All right, we're starting at negative 3x. Boom. My stylus is just going wonky. Plus 21 times p times x equals 84. Let's get this 21px by itself. Let's add 3x to both sides. So I'm going to get 21px equals 3x plus 84. Okay, now we've got this 21px and we've got 3x. Well, what would happen if 21p was equal to 3? Then I would have 3x equals 3x plus 84, and that would be impossible. That would be an impossible one. It's like, that I think is our way here. What if we said that 21px is equal to 3x? Let's solve for that, and then we'll get a p that we can plug into this equation and make it impossible with no solution. All right, so we can divide both sides by x to get rid of those x's. So I get 21p is equal to 3. And then to solve for p, I need to divide both sides by 21. And I get that p is equal to 3 over 21. If I simplify that, because 3 goes into both of those, it goes into 3 one time, it goes into 21, 7 times. So p is equal to 1/7. If I plug 1/7 in here, that's what I'm going to get. I'm going to get 3x equals 3x plus 84, which is impossible. There's no solution to that. So B, 1/7 is my answer. Number 18, f of x equals x minus 10 times x plus 13. The function f is defined by the given equation. For what value of x does f of x reach its minimum? And I'm sure some of you are immediately saying, I'm going to graph that. And that's fine. That's totally fine. There's a way I'm going to show you. I think if you've got it down pat, if you've got this in your head really solidly, could be a little quicker, save you a few seconds. But both ways are equally fine. If you are graphing it, it's going to give you a parabola that opens up, and you're going to look for its minimum. You're going to look for that vertex, and whatever ordered pair they give you for the value of the vertex, you're looking for the x, because it says for what value of x does it reach its minimum. So that's how you would graph it. Just be very careful with graphing. Always make sure that we're not making any typos, because that's the worst. If you make a typo on something, they're like, hate that. I've done it myself. Right, now here is the other way that you can do this. And this is just a good formula to have in your tool belt, in your toolbox for the SAT. The formula for the vertex, or the axis of symmetry, I should say, which goes through the vertex of a parabola, is x equals negative b over 2a. So if you do this, you will get the x coordinate of the vertex, because it is the axis of symmetry that goes through the vertex. X equals, it's that vertical line. Right, so we need the b and we need the a, and we are talking about when we have ax squared plus bx plus c. When we have the quadratic in that form, we're looking for the number next to the a, the number next to the b, put the opposite of the b on top, multiply the a by 2, and there we've got our axis of symmetry and our x value for that vertex. So here we have x minus 10 and x plus 13. If we start to do FOIL, we don't even have to finish it, but if we start to do FOIL, okay, x times x, there's my x squared, so I already know my a is 1, 2 times 1. And then to get my b, I'm going to multiply the x's out. Negative 10 times x is negative 10x. X times 13 is positive 13x. I don't need to worry about the last one because I don't need c, I just need b. Negative 10 plus 13 is positive 3x. Okay, so the opposite of 3 is negative 3. All right, negative 3 over 2. Done. That's it. That is my x value for the axis of symmetry. It is the x value where it is its minimum, and it is d, negative 3/2. So for me, when I'm looking at that, to me, that is quicker. It's not quicker for everyone. You know, it's going to depend on the student. It's going to depend on your comfort level, what you know, what you are most comfortable working with, what you are, you feel confident in. We want confidence. So those are the two ways to do it, this and graphing. Please just pick whatever works best for you. Number 19. The function f of x equals 1/9 times x minus 7 squared plus 3 gives a metal ball's height above the ground, f of x in inches, x seconds after it started moving on a track where 0 is less than or equal to x is less than or equal to 10, Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane? Okay, before I look at their options, I'm going to look at this parabola. Now you absolutely can graph this by just putting it in your graphing calculator, putting it in Desmos. Totally fine. Honestly, I think it's a little faster if you're very familiar with how these numbers change our basic parabola. You can sketch this pretty quickly. I think it's faster than going to Desmos. Every second counts on the SAT. So I'm going to show you, what you're going to get either way. Okay, so here is, the sort of principle about translating functions on the xy plane. If I just have an x squared, it's going to be a parabola that opens up and the vertex is at 0, 0. That's just, x squared. Now there's all these different numbers, all different things we can do. I can put a negative in front of the x squared. I can put a number in front of the x squared. I can, add something to the x squared or subtract something. Or I can put in, the number inside here. Each of those moves this in a very specific and predictable way. So one by one, if you have a negative out front, a negative x squared, it flips it upside down. If you have a number in front of it that is greater than 1, it's going to squish it and make it narrower. If you have a number in front that is positive but less than 1, a fraction that's less than 1, it's going to make it wider. If you have a number outside of the x squared, it's going to move it on the y-axis exactly as you see it. So here plus 3, it's going to move it up 3 points. Nothing else will change, it's just going to go up 3. If you have a number that is inside the x squared, it moves it left or right, but it moves it the opposite way. So x plus 3 would move it 1, 2, 3, 3 to the left towards the negative x. And you can combine all of these together, which is what's happening right here. Again, if you have these rules down pat, you can look at this right here and go, okay, so I'm starting with an x squared, just a plain x squared, and it's positive, so it's still opening up. All right, that 3 is going to move the vertex up 3 points. And then that minus 7 is going to move it the opposite, so plus 7 on the x. 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to be there, and 1/9 means it's wide. Okay, so I've got a wide parabola with a vertex at 7, 3. Okay. Now see, I did that little quick sketch just by looking at that. Personally, I think I could do that faster than going over to Desmos and typing in f of x equals 1 divided by 9, parentheses, x minus 7, parentheses squared, plus 3. It's up to you. They're close. They're close. But for me, I don't like flipping back and forth as much. I like staying where I'm at. And if I can do it pretty quickly this way, that's what I'm going to do, because that's what works for me. And we're also told it's where x is between 0 and 10. So it's starting here, and it's going to 10. It's about like there. Okay. And it's, it's going to cross. I don't know where it's going to cross, but, it's starting there. And this is what's happening to this metal ball. Right, so which of the following is the best interpretation of the vertex of the graph, this 7, 3? And we are told, actually, just to make sure, the ball's height in inches, so this is inches over here. My y is inches, and x seconds. So my x over here is seconds. So that applies also to the coordinates. This is 7 seconds, 3 inches. So let's look at our options. What does this, at 7 seconds, it's at 3 inches, mean? Which of the following is the best interpretation of the vertex? Option A, the metal ball's minimum height was 3 inches above the ground. Yeah, that looks right, because it was going down and then it came up. This is a minimum point, and it was at 3, and we said that the y is inches. It's like, hey, A looks like our contender. B, the metal ball's minimum height was 7 inches above the ground. No, the 7 is how many seconds after it started rolling. It's our seconds, so no, B is not our option. C, the metal ball's height was 3 inches above the ground when it started moving. Nope, that would have been over here somewhere at 0, and then it went down 7 seconds later. So it was not at 3 inches when it started rolling. It was higher than that. And D, the metal ball's height was 7 inches above the ground when it started moving. Same sort of thing as 7 inches. You know, I don't know. If I did the value of 0, I could find out how many inches it was above the ground at 0 seconds. I don't think it was, at 7 inches, but I would have to do that math to be sure. But it doesn't matter because it's not asking about what happened when it started moving. It's asking about the vertex, which is 7 seconds later. So both of these that are talking about things when it started moving. No. A is absolutely our answer. It was 3 inches above the ground at its minimum. Number 20. In triangle JKL, the cosine of x is 2451 and angle J is a right angle. What is the value of cosine L? Okay, so I've got a triangle JKL and I'm told J is a right angle. So JKL. And the cosine of K is 24 over 51. Now cosine is adjacent over hypotenuse, the length of the adjacent side over the length of the hypotenuse. So my adjacent on top is 24, so that's this side that's adjacent to K. This is the side that's opposite, this is the leg that's adjacent, and the hypotenuse is always the longest side, the one opposite the right angle. So hypotenuse then is 51. And that 5 looked really weird. There we go, 51. Okay. Now, there are a couple of different things you can do at this point. We can go ahead and use a squared plus b squared equals c squared to solve for our missing side because we're going to need it to find the cosine of L. Because for L, we need the adjacent side of L over the hypotenuse, so we need that side. So we can absolutely plug in and say a squared plus 24 squared equals 51 squared. Sometimes with these right triangles, it's beneficial to look and see if it might be a triple, a Pythagorean triple, meaning one of our common triangles that has those nice round numbers like 3, 4, 5, or 5, 12, 13. There's a few of them. And that's something, if you want to learn those, they can save you a little bit of time. It's up to you. So in this case, I looked at them and I said, these are both divisible by 3. What happens? 15 divided by 3 is 17. 24 divided by 3 is 8. Ah, yes, that is one of those triples of 8, 15, and 17. Which would mean, since this is 17 times 3, 8 times 3, then this side would be 15 times 3, or 45. Again, that's a little, kind of bit of an extra. that shortcut is a little extra. If that makes sense to you, that's something that you can use. Absolutely. If you want to just stick with our, solving using the Pythagorean theorem, totally fine and will always work as well. Okay, so if we do this, my 51 squared is 2,601. My 24 squared is 576. And then we have a squared plus that. If I subtract 576 from both sides, I'm going to get that a squared is equal to 2,025. And to solve for a, I need to take the square root of both sides. And I'll get that a is equal to 45. Right, so the value of cosine L, either way that we looked at this, we saw that this is going to be 45. And the cosine of L has to be the adjacent over the hypotenuse. So the cosine of L is the adjacent side, 45, over the hypotenuse, 51. Always check to see if you can simplify this. So simplify. And I will say, I've heard that they said they don't penalize you for not simplifying, but then if you look at their answers, they always have it in, they're like, simplify this down to that. So, let's, what's the word? Not like hedge your bets, but maybe it is hedge your bets. Let's hedge your bets and simplify this. Both of these are divisible by 3. So if I divide 45 by 3, I get 15. If I divide 51 by 3, I get 17. So my simplified answer is that the cosine of L is 15/17. And that is my answer. And you can put it in that fraction form or in a decimal. Number 21, negative x squared plus bx minus 676 equals 0. In the given equation, b is a positive integer. The equation has no real solution. What is the greatest possible value of b? They are testing whether you know about the discriminant. It is that when we have the quadratic formula of negative b plus or minus b squared minus 4ac all over 2a, this underneath the square root is our discriminant. It determines how many solutions there are. If this turns out to be a positive number, you can take a square root of a positive number, and then you'll be negative b plus or minus that positive number, so that is 2 options. If it is 0, then square root of 0 is just 0, so it'll be negative b plus or minus 0. It won't change it. There will be only 1 solution. And if it is less than 1, then it is square root of a negative number. There are no real solutions in that case. So they want you to use this b squared minus 4ac and set it up in such a way that there would be no solutions. So b squared minus 4ac would have to be less than 0, not less than or equal, because if it's equal, there's 1 solution. It has to be less than 0. Okay, so let's plug in our numbers from over here. B is just b, so it stays b squared minus 4 times my a is that invisible number 1 that's in front of the x, and it is a negative 1. And my c is negative 676. Okay, so 4 times negative 1 times negative 676 is 2,704. So I get b squared minus 2,704 is less than 0. So to solve for b, I'm going to add 2,704 to both sides. And I get that b squared is less than 2,704. Then I need to take the square root of both sides, and I get that b is less than 52. And I guarantee you there will be students that will put 52 as their answer, but it is not, because it says b has to be less than 52, not equal to it. If it is 52, this would have a solution. And we are told it is a positive integer, so no fractions or decimals. So what is the greatest, because that's what we want. We want that greatest possible integer. Why is it not erasing? There we go. We want the greatest possible value of b. So what is, boom, the greatest number that is less than 52? Greatest integer less than 52 is 51, and that is my answer. Number 22. If a new graph of 3 linear equations is created using the system of equations shown, and the equation x plus 4y equals negative 16, how many solutions, x and y, will the resulting system of 3 equations have? When we're talking about systems of equations and we're graphing things, the solutions are going to be where the graphs cross. So if I have 2 lines, it's going to be that point where they cross. If it is a parabola and a line, it'll be the 2 points where they cross. When we get 3 equations in that system of equations, it doesn't change. It still has to be a point that is on all 3 of them. Now when they're lines, there can only be 1 possible point. I'm not quite drawing that right. Come on. There we go. There's only 1 spot where if I draw 3 lines that all 3 could intersect, and that's only 1. It's not possible. None of these lines are bending, so I can't have it come back and then no. Straight lines, it's only going to be that 1 spot. 1 is the maximum. So this right here, our little options, we have 0, exactly 1, exactly 2, or infinitely many. 0 is a possibility if I have 3 systems of 3 lines in this system of equations, because actually I want to draw them in different colors so you can really see this here. So like if I had a line that goes like this, that doesn't go through this other point at all, then that would be 0 solutions. If it goes right through the middle, that would be 1 solution. 2 is not possible. Cannot intersect twice. Lines never intersect twice. Lines will either have, if just I'm speaking of just 2, but this also applies to 3 lines. If I have these 2 lines, it will either be one solution, no solutions, or infinite solutions. Infinite solutions only happens when you have a line and then you have another line that's right on top of it. So it is possible that you could have infinite solutions to a system that had 3 equations in it. But look at what we're starting from. We got this one line going diagonally there, and then we have this other line going straight. It's a little hard to see, honestly, the way they've drawn it. But these are not overlapping lines. So, I mean, already the infinitely many is not an option, because that's the only way it could be infinitely many, is if my first 2 lines were drawn right on top of each other, and then this third line that they're giving us that we have that is not currently drawn on there, if it also was overlapping. But that's not happening. We've already got a point of intersection. So the second one here, look at here, exactly 2, impossible. Lines that intersect, whether it's 2 lines, 3 lines, 4 lines, a million lines, the maximum number of solutions, if there is concrete number and it's not infinite, is 1. That's it. 0, 1, or infinite. Those are the only options when we're talking about lines, because they don't bend. So now we're just down to 0 and exactly 1. Now, 2 ways that you can do this. Personally, I like sketching things. I'm pretty quick about sketching them. So I would probably just sketch it where it's at and then see if it's going to be heading towards this point, if it's going to intersect there as well. You can also put it into your graphing calculator. Now, there's one little wrinkle with the graphing calculator, which I'll get to in a second. Let's start with doing it manually, as it were. If I have x plus 4y equals negative 16 and I want to graph it, for me, slope-intercept form is going to be the best way to graph this. And actually, there's a second way you can do this mathematically. I'm going to show you both ways. Okay, so first way, if I'm just going to sketch it, I'm like, all right, I'm going to turn this into slope-intercept form. I'm going to get the x's over on the right. So now I have 4y equals negative x minus 16. I'm going to divide everything by 4 to get rid of that 4. And that is going to give me y equals negative x over 4, or negative 1/4 x. Negative 16 divided by 4 is negative 4. All right, so I've got a line that has a y-intercept of negative 4, and the slope is negative 1/4. So I know, even before I draw anything, I know it's not going up here because it has a negative slope. If you're going left to right, like how we read in English, and it's going down, that's negative. Like, oh, he brings me down, man. He's just like, oh, he's such a negative person. I go down. Whereas positive goes up if we're going left to right. So a negative, I know it's heading down this way. There's no way that line is going to come up here and hit that. It would have to be a positive slope. So if I want to draw it in to confirm, a negative 1/4 is rise over run. So I'd go down 1 and I'd go to the right 4. There's my other point. Boom, there's my other point. Oh, it hates when I draw dots. Ah, it just freaks out. It's like a dot. Oh, good Lord, what am I going to do? It's a dot. Sorry, it just it has such issues with dots. I don't know why. But it's going to be something like that drawn through there. Yeah, it's not intersecting at this point. So that's one way. You can do a quick little sketch of it and you're done that way. Another thing you can do is you can take this point that is the point of intersection that we see, boom, that we see up here that they've already kind of highlighted, and it's right there. And that point is 8, 2. And we can plug those numbers into here and see if it makes a true statement. You don't even have to draw it. See if that works. So if x is 8 and y is 2, 8 plus 4 times 2, or 8 plus 8, does that equal negative 16? No, that equals positive 16. So there's another way of looking at it. Nope, it doesn't work. It will not go in there. If you are graphing this, don't worry about graphing the 2 lines that I have highlighted here, the 2 original lines in the system of equations, because all you really need to know, again, is that one point. That's it. So don't worry about trying to figure out what the equations of these lines are and graph them, because that's going to take you way too long. All you need to do is put that equation into your graphing calculator, and as we showed you, it's going to give you something that looks kind of like that for the line. And then you can either reference back to this and go, hey, it's not hitting that up there. Or you can actually just type into Desmos that 0.82 along with your equation, and it will put your little point up there, and then you can see quite clearly it is not on that line. So yeah, there is no solution to this system of 3 equations. A, 0 is my answer, and there's 3 different ways that you can figure it out. Pick the one that works best for you, that you understand the most, and that is the fastest for you. Number 23, f of x equals 5,470 times 0.64 to the power of x to the 12th. The function f gives the value in dollars of a certain piece of equipment after x months of use. If the value of the equipment decreases each year by p% of its value the preceding year, what is the value of p? Okay, I'm going to rewrite this. 5,470 times 0.64 times x to the power of 12. And we are told x is the number of months, and that if I do this math, I will get the value in dollars, the value of this. And I'm also told the value decreases each year, and they're underlining this. They really want you to take note. It's decreasing each year. How much is it decreasing by? What percentage? Well, look at this equation. What's going on here? I have this 5,470. That is the starting value of this equipment. And then after so many years, how do we know how many years going? It's decreasing. Now it's being multiplied by 0.64 to the power of the months divided by 12. What happens when we divide months by 12? If I told you I have 12 months and I were to divide that by 12, I would get 1. 12 months is 1 year. So by dividing by 12, I've determined how many years that number of months is. So that same thing, like if it was 36 months, if I divided it by 12, I would see 3. And yes, 36 months is 3 years. So that's what's happening up here. Let me say this is months divided by 12. So I could replace this and just say it's, I'm going to call it y and say that y is years. Because it's the same thing. X over 12 is the same as how many years. So every year, because after 1 year, 5,470 would be multiplied by 0.64 after 1 year. After 2 years, it would be multiplied by 0.64 twice. 3 years would be multiplied by it 3 times. So this right here is what's causing the decrease. But by what percent is it decreasing? Is it decreasing by 64%? No, if I multiply 5,470, if I multiplied it by 1, what would happen? I would just get 5,470, right? It wouldn't change. If I multiplied it by 0.99, I would get a number that is 99% of that 5,470, meaning it had decreased by 1%. If this were by 98, I'd get a number that was 98% of this. So my result would be this number decreased by 2%, and so on. So here we have 64. What percent decrease is that? Well, we're starting at 1 or 1.00. That would be no change. But instead, we're multiplying this number so that my result is 64% of the original. So what was the decrease? I can say 100% minus 64%, or 1.00 minus that 0.64. Both will give me the same answer of 0.36 or 36%. And my question is, if we go back to the question is, what is the value of p? What is that p percent? It is 36%. This is decreasing by 36% every year. Number 24. The dot plot represents the 15 values in dataset A. Okay, dataset B is created by adding 56 to each of the values in dataset A. So I'm going to make my little dataset B and 56, because originally we started with 22, 23, 24, 25, 26, and 56 was added to each value. So 22 plus 56 is 78. 23 plus 56 is 79, 80, 81, 82. Okay, if we look at the dots, let's see, we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 1, 2, and 1. Okay. So which of the following correctly compares the medians and the ranges of datasets A and B? Well, before we look at all of their comparisons, because there's a lot of words there, let's get an idea of what we're looking for. Medians and ranges. What is the median? The median is if I have a list of numbers. The median is the number that is the middle number in that list. So here there's 5 numbers. The number that's in the middle of that list, 7, is the median. If it is an even number of terms, like if there was one fewer here, then you would take the middle 2 numbers and average them. That is median. So the median, I'm not even going to really calculate it, but I just know the median in dataset A is going to be somewhere in here, right? I don't have to look at the exact, I don't have to count up how many they are and see. I know the median is going to be between 22 and 26. Over here, is that the same? No. The median is going to be between 78 and 82. All right, so I already know the median of B is going to be greater than the one of A. Just of necessity, without even calculating what the median is. Now what about the range? The range is the difference between the smallest and the biggest number in the data set. Well, here, from 22 to 26, that is a difference of 4. Here, 78 to 82, that is a difference of 4. Those ranges are the same. So the range of B is equal to that of A. And now I just need to go through here and find something that matches what I've already said. Okay, median of B is equal to, already gone because I know they are not equal. The median of dataset B is equal to, nope, that one's gone too. The median of dataset B is greater. Okay, that's possible. Median of dataset B is greater. Yep, both possible. Now I need to see which one says the range is equal. The range of dataset B is equal. Hey, I think we have our answer. Let's check D just to be sure. The range of dataset B is greater than. Nope, that one's out. C is my answer. Number 25, the equation x squared plus y minus 1 squared equals 49 represents circle A. Circle B is obtained by shifting circle A down 2 units in the xy plane. Which of the following equations represents circle B? This is a great equation to know. They love equations of circles. And the equation of a circle is one of those that looks fancy, but it really isn't. So it's x minus h squared plus y minus k squared equals r squared. And in this equation, the h and the k are the coordinates of the center, and r is the radius. So if I had x minus 2 squared plus y minus 5 squared equals 16, that is a circle with a center of 2, 5, and a radius of 4. So you see how that would be pretty easy to draw, right? Because the center is always hk, and note this is minus h and minus k, so negative 2 becomes positive 2, negative 5 becomes positive 5. That's the only sort of thing in here you got to keep your eye open for. So the other one, come here, don't want the eraser. There you go. If this was plus, then it would be negative 2, negative 5 for the center, and still the radius would be 4, the square root of 16. Okay, so with that in mind, let's look at, there we go. Let's look at what they've given us. They were told that x squared, come on, there we go, x squared plus y minus 1 squared equals 49. Now you may notice there is no h. There's nothing here. When that happens, it's just 0. the x is going to be 0. So I know the center of that x is at 0, and that -1 means the y coordinate there is 1. The radius squared is 49, so the square root of 49 is 7. So I have a little circle that has a center at 0, 1, and it's got a radius of 7. Now it's saying that this new circle, circle B, is obtained by shifting this circle down 2 units. All right, so if I'm at 0, 1, and I want to go down 2, what is that going to be? If I go down 1, it's going to be at 0, 0. I go down 1 more, I am at 0, -1. Okay, so that's all it is. The circle has just gone down to the new center of the circle is 0, -1. The radius has not changed. So what would be the equation of a circle with a center at 0, -1 and this same radius of 7? All right, using our x minus h squared plus y minus k squared equals r squared formula, my x is still, my x coordinate for that center is 0. So x minus 0 squared, that still just stays as x squared. And then y minus k squared, the k there is -1, so this is going to be y plus 1 squared. And the radius squared, still 7 squared, is 49. So I'm looking for x squared plus y plus 1 squared equals 49. And that would be D. There is my answer. Now you can graph this if you forget this, but honestly, once you have this in your head, and you can just kind of look at this and go like, okay, so the center there is at 0, 1. It's going down 2. That would make it 0, -1. All right, let me write that equation. That's a lot faster than what you would have to do if you were graphing it, which would be that you would have to you'd have to graph this top one, and then you'd have to graph all of these and see which one of them was going down. That's a lot to type in. So in this case, definitely knowing the equation of that circle would be a big help time-wise. All right, number 26. 2 identical regular prisms each have a height of 90 centimeters. Okay, this is an odd duck problem, so I'm going to start drawing things here. All right, so I've got a rectangular prism, and I've got 2 of them, and they're both 90 centimeters. They are identical. Okay, the base of each prism is a square. Okay, good to know. So I don't know what they are, but I know it's a square, so I'm going to call both of these sides x. Right, the surface area of each prism is k centimeters squared. Okay, so what is surface area? It's when we add up the area of all the individual sides. So for each of these individual prisms, just look at one of them here, what would the surface area be? Well, the bottom square would be x times x, or x squared. The top square would be the same, x times x, or x squared. So together those would be 2x squareds, x squared plus x squared. Now, the 4 sides, each one of those is going to be 90 times x. It's going to be 90 times x all the way around. So I have 90 times x, 90 times x, 90 times x. So I have 90 times x, and I have 4 of those. So 2x squared for the top and bottom. 4 times 90 is 360. And all that added together equals k, the total surface area of 1. Okay, so I'm going to remember this. I'm going to write it over here, that 2x squared plus 360x equals k. Okay. All right, so the next part, what's the next thing that they tell us? If the prisms are glued together along a square base. I have seen this verbiage before. The first time I saw it, I'm like, what are you talking about? What they mean is, if I take these 2 prisms and I glued them together so that a square base is touching like that, that's what they mean. If they are glued together like this, the resulting prism, boom, 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 has a surface area of 92 4/7 k centimeters squared. Okay, now here's something else we're going to look at and think about here. when these two were separate, what was their total surface area? They each had a surface area of K. So together, the original surface area was K plus K, or 2K, when you added them together. Now they're glued together. And what has happened? So the new surface area is 92 47ths K. All right? Okay. So what does that mean? What happened? What disappeared? We've gone from 2K to 92 47ths K. What is the difference between these? If I change 2 into 47ths, so if I want to change that, I would need to multiply 2 times 47 over 47, and I would get 94 47ths. Okay, so when they were separate, they had a surface area of 94 47ths. And I'm going to write that up here. 94 47ths K. And now they have 92 47ths K. So if we subtract 94 minus 92, we can see it has changed by 2 47ths K. So what is 2 47ths K equal to? Well, what's vanished? Each of them has lost a bottom square. Because when they were separate, right, when we had the two separate rectangular prisms, we had 4 sides on each of them, so 8 sides total, and then we had 1, 2, 3, 4 squares. Well, now we still have the 4 sides, we have those 8 sides total, but we only have 2 squares, not 4. 2 of those squares have vanished. So the 2 squares, which are, again, x times x, the 2 squares, the 2x squareds, are the same as 2 47ths K. All right. Now, I want to be able to solve for this. I want to try to find a way to solve these two. I am going to get K by itself. I'm going to get rid of this 47 halves. If I do that, if I get K by myself, I will have K equals something, and over here I have K equals something. I can set those two somethings equal to each other. And I'll just have just x's, and I can solve it. Okay, so 2 47ths K. In order to get rid of that, I need to multiply by 47 halves. That will cancel out those fractions. You multiply by the reciprocal. So I'm going to do the same on this side, multiply by 47 halves. And then on the right side now, I will just have K, and on the left side, those 2's cancel out. And I'm left with 47x squared. Okay, so I know that 2x squared plus 360x is K, and also that 47x squared is K. So I can set them equal to each other. So now I have 2x squared plus 360x equals 47x squared. I'm going to subtract 2x squared. Nope, stop, go away. Subtract 2x squared from both sides. I was trying to keep this all on one page, but I'm just running out of room as usual. And so I have 360x on the left, and 47x squared minus 2x squared is 45x squared on the right. I can divide both sides by x to get rid of one of those x's. And then I will just have 360 equals 45x. And to solve for x, x is being multiplied by 45, so I want to divide by 45. And I get that x is equal to 8. All that. X is 8. And let's double check and see what our question was when we started all this. What is the side length in centimeters of each square base? And lo and behold, yes, x is what the variable that I assigned to that. X is 8, so B, 8 is my answer. The other way you can do this, it doesn't cut out a whole lot of work, but it's just, you have to understand the core concept of what's happening, that what's disappearing, what's reappearing, and that you can plug and play, by which I mean you can take all these and sort of plug them in and say, okay, if this side were 4, because they give the choices of 4, 8, 9, and 16, if this length of this square was 4, what would the total original surface area be? What would the new surface area be? Would it be equal to this proportion? That's the other way you can do it. I don't know that either of those is much faster than the other. It's a tricky little, it's an odd problem. It just is. All right, number 27, home stretch from the last one. 210% is p% greater than 30. What is the value of p? If you're doing this in an equation form, we'd say that 30 is being multiplied by 1 plus the percent increase. That 1 is taking care of the 30, and then we're going to have the percent increase. If you just put p here as the percent increase, that's fine, frankly, but you have to realize that this is representing 100%. So this would also be representing the whole number version of a percent, and you'd have to convert it. If you don't have that sort of like ingrained thought process about percents, then you need to treat it this way, where it is p over 100. So it is that percent divided by 100 would give you that decimal, that whole number. So again, this is just about what makes the most sense to you. Honestly, in your textbook, this is the way you're going to see it. So if I multiplied it by 1 plus the percent increase divided by 100, it's going to give me that 210. And then to solve for that, I could distribute, but honestly, with that fraction, it's going to be easier just to divide everything by 30 instead of distributing. And then I will get that 1 plus p over 100 equals 7. Then I would subtract 1 from both sides to get rid of that 1 that's by itself. And you end up with p over 100 equals 6. You multiply both sides by 100 to get rid of that dividing by 100. And you'll get that p is equal to 600. So 600%. And again, like I said, if you just treated this as p, then you would get that p equals 6, and you'd have to remember this is 100%, so 6 would mean 600%. We just don't want to do anything that will cause confusion. You want to do it in such a way that makes sense to you. So final answer then, 210 is p% greater. It is 600% greater than 30. That's your answer. And you made it to the end. Congratulations. Hey guys, just a quick heads up. I've got some cool stuff coming for y'all, including a free course full of SAT tips and tricks, as well as an exhaustively complete course on everything you need to know for the SAT, both math and reading. So subscribe to the channel to get notified when that goes live. I'm also going to put it in the comments and description below as soon as it does. In the meantime, if this video was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.